The principle of this system is to control the pump based on the water level measured by an analog sensor. When the start button is pressed, the run light turns on, and the system is ready to operate. If the actual water level is less than or equal to the set min level, the pump will run, because the water level in the tank has dropped. If the water level is greater than or equal to the set max level, the pump will stop, because the water level in the tank is full. This system can simulate the water level sensor on the HMI using a simulation button. Pressing the stop button will stop the system. Using the content from the previous lesson, delete the sensors. Remove the on or off sensor simulation button and replace it with an analog level. Using the bar function, set the properties for the bar. Follow my instructions. Back to the Symbol factory software, and I will use a water level sensor. Add an I/O field to display the actual sensor value. Create I/O fields to set the max and min water levels. Back to the PLC. In the tag control section, delete sensors S1 and S2. And replace them with an IW tag for the analog water level sensor, formatted as an integer. The default address of the PLC is IW64. You can see here the default address is IW64. This is the input address, requiring a tag to convert from input to a 0 to 100 water level. I will create an additional tag for the actual water level formatted as a floating point. The memory area is MD200. Add 2 real tags to set the max and min water levels. Back to the main program to programming. Delete the error tags from the previous lesson and add a new network. Use the norm and scale functions. The sensor's minimum value is 0, and the maximum value is 27,648. Create an intermediate tag for the norm block's output and drag this tag to the norm block's output and the scale block's input. Set this block's output value from 0.0 to 100.0. And the output is the action level. Because the water level signal can be simulated on the HMI using the simulation button, it is necessary to place a normally closed bit of the simulation tag before the norm function. I will delete this network to reprogram it according to analog signals. The pump will only run when the run lamp is on. Compare if the actual water level value is greater than or equal to the setting level max. Then reset the pump because the tank is full. If the actual level is less than or equal to the setting level min, set the pump. Because the tank is empty, when the run lamp is off, the pump will also reset. Back to SCADA to assign tags. Setting level max uses the PLC level max tag. Here, I show two numbers after the dot. Similarly, for setting level min and actual water level. The actual water level ranges from 0 to 100. For the buttons or symbols from the previous lesson, I have assigned tags. Run the simulation and check the results. When there is an error, delete the tags with red warning signals from the previous lesson. Then back to the screen and run the simulation again. Set the max water level to 90 and min to 5. Then press Start. When the actual water level is less than min, the pump runs. Simulate the actual water level rising. Because I haven't enabled the simulation feature, I can't set the actual water level. Enable the simulation function. Now, we will simulate the water level rising. And when the water level exceeds 90, the pump stops. When the actual water level drops below min, the pump runs again. To simulate the automatic water level increase, back to the PLC, enable the system and clock memory function. In the main program, simulate the automatic water level increase when the pump runs. Use clock 1 Hz and the add function to increase the actual water level by 2.5 units per second. You can choose a different value to replace this 2.5. The add function automatically increments the tag value by 2.5 units every second. Prevent continuous water level increase by using a pulse command. When the pump is not running, if the water level is greater than 0, I program it to automatically decrease the water level using the sub function. I also use a 1-second pulse to decrease the water level. Only increase the water level value when it is less than 100 using a comparison command. This function is only active when the simulation button is enabled. Then, download the program to the PLC and run the runtime. Now I'm simulating, but the water level is not increasing. Why? Because the clock pulse is not working. To activate the pulse, you need to download the hardware. By clicking on the PLC and selecting Hardware Download. Now, the water level will increase by 2.5 units per second. When the water level exceeds 90, the pump will stop. When the pump stops, the water level will decrease, because we are using the subtract command. When the water level drops below 5, the pump will turn on again. And the water level will automatically increase.